Good morning, students. Let's start with the chapter 9, Study of Compounds, Ammonia, on the page number 151. As you know, the ammonia has the formula NH3, N for the nitrogen, H for the element hydrogen. Its compound is forming and NH3 is there. When we are considering the relative mass or relative molecular mass of ammonia, that is 17. Now the question arises, how this 17 is coming? As you know, the formula of ammonia is NH3. In that, nitrogen have the atomic mass 14, hydrogen having atomic mass 1 into 3 that is 13, 14 plus 3 that comes the 17. In case of ammonia, if we consider its structure or Lewis diagram, or you can say that is your electron dot structure. I have highlighted this one. Kindly check it. In that one, nitrogen as a central atom is present in between the structure and the hydrogen along that central atom and at the side one. Nitrogen having its valence electron which are shown by the circular dots and hydrogen with the cross one. In nitrogen, the valence electron are 5. You can check it that the 5 dots are being formed. And hydrogen with the valence electron 1 and 1 cross each of the hydrogen is there. Here one thing is very important that there is a presence of a lone pair. What is lone pair? The unshared pair of electron which are not participate in the bonding that are called lone pair. In this structure also, you can consider the lone pair is there which are not participating in the bonding. That structure which I have highlighted it is a bonding structure. And that structure you have already covered in your chemical bonding chapter. After that, one thing that is which type of bonding is present. Check it. Here the covalent bonding is present. In case of ammonia, there is a presence of a covalent bonding. The reason is that the sharing of electrons are going on. If the sharing of electron is there, then your what? Covalent bonding is there. Another major reason is there. The electronegativity difference between the nitrogen and hydrogen is less. And in that condition, the covalent bonding is going on. Here, 3 single covalent bonds are being formed. I'm repeating, 3 single covalent bonds are being formed between the nitrogen and hydrogen. I'm showing that, kindly check it. Which 3 single covalent bonds are there? One is this, second is this, and third one is this one. These are the single covalent bonds which are being formed in case of ammonia. And that is a very important your point. Kindly consider it thoroughly. After I am coming to the occurrence. Occurrence means in which form it is present. First is the free state. Free state, in case of the free state, it occurs in two forms. One is in air and second is a natural water. In natural water, it is present in traces, whereas in air, in the small amount, it is present. Next is the combined state. In combined state, it is present in so many compounds. The reason behind is that in combined state, the ammonia or in general the ammonia as it is highly soluble in water, it is not present in the mineral. There's so many compounds are being formed which we are studying and so many compounds are there in the lab which we can study further on also, and these are that compounds which are very essential. One thing that is a very important point here. That is, the ammonia has the pungent smell. A peculiar odor is there with ammonia that has the pungent smell. That pungent smell normally you will encounter when you're passing your washrooms or a toilet area. Now the question again arises, why this peculiar odor is present by the ammonia? The reason behind is that when the urine come in contact with the water, then the ammonia, water and carbon dioxide is forming, or in chemical sense, you can say due to the bacterial decomposition of urea. This urea is eliminating from the body and it is being reacted with the water and there will be a formation of ammonia, and that ammonia result into the peculiar odor or the pungent smell. Next, your point is coming about the forms. Forms means types. In how many types the ammonia is present? Ammonia is present, number one, in the gaseous form. That is the gaseous ammonia. Gaseous ammonia means the dry ammonia. That dry ammonia is always being present when it is being dried up by the drying agent. And when this gaseous ammonia coming under the contact of pressure, or in short, when we are increasing the pressure, it will convert to the liquid ammonia. It means the dry ammonia, by increasing the pressure, it will form liquid ammonia. The next thing after these 2 points is your liquor ammonia fortis. Very, very important point. Liquor ammonia fortis. What the meaning of this liquor ammonia fortis is there? Liquor ammonia fortis, it is a saturated solution of ammonia in water, and we are calling it 880 ammonia. Means when the saturated solution of your ammonia and water is being there, then it is your liquor ammonia fortis. And when this liquor ammonia fortis is being diluted, when we are diluting it, when we are adding more water, it means we are converting it from the saturated to unsaturated. Then it is your what? Then it is your laboratory reagent or laboratory bench reagent. Laboratory bench reagent is formed when your liquor ammonia fortis or liquor ammonia is being diluted. Then this one is forming. It means under the forms, the different forms are there, which are, first is your gaseous ammonia, second is your liquor ammonia, third one is your liquor ammonia fortis, and fourth is your laboratory reagent. That are the types. After completing this one, forms, we are coming to the very important point, that how to prepare ammonia. What are the ways by which the ammonia can be prepared? Before starting the preparation methods, we have to first study the states in which the ammonia is present. The first state is your gas form. Gas form means your dry gas in the gaseous form. Second is the aqueous form, when in this gas water is present. As you know, ammonia is highly soluble in water, then aqueous form is present normally in its preparation. After completing this one, next is your methods, in which by which methods we can prepare it. The first method is your journal method. General method of preparation means by mixing the two chemicals and after that the ammonia is forming, then it is your general method. That is your general method. Second is the laboratory preparation. Laboratory preparation means all that chemicals when are being used in a particular proportion and prepared in the lab, then it is the laboratory preparation. And third one is the manufacturing. When this ammonia preparation is being manufactured industrially, means at the large scale, at the mass scale if it is prepared, then we are calling it manufacturing. These all are the different types for the preparation of ammonia. Now, in detail, we are coming. First is the general method of preparation. Under the general method of preparation, one thing students consider it carefully, that is how this one general method activate. I'm highlighting that portion, kindly check it. Ammonia salt when react with the alkali and that is being heated, then the salt, water and ammonia is forming. Ammonium salt, I'm repeating again, we are taking here the ammonium salt. That ammonium salt can be in the different form, in ammonium chloride, in ammonium sulfate, in ammonium carbonate, in any form it can be there, right? It should be a ammonium salt. Next is the alkali. That alkali participate a very major effect. Here one thing is there, the slag lime. Slag lime we are using because it is a cheap, it is easily available and it is non-delinquent in nature. Caustic potash or caustic soda. Caustic soda with the formula NaOH, caustic potash with the formula KOH. When these two things are being treated and the heating is going on, then there will be a formation of a one salt with water and ammonia gas. This ammonia gas, I'm repeating, this ammonia gas have a peculiar odor, that is the pungent smell, and we can identify very easily that ammonia is present. Students, these are the general method of preparation which are in your syllabus. You have to write all these directions and learn it thoroughly. After that, your what? The laboratory preparation is coming. Laboratory preparation is very, very important and mostly it is coming in your exam. For the laboratory preparation, the first method is from the ammonium chloride. I'm highlighting that one, kindly check it. Ammonium chloride. From the ammonium chloride, but only ammonium chloride is not enough. What we are using here? We are using the calcium hydroxide also. With the ammonium chloride, we are using a calcium hydroxide in the ratio of 2:3 by weight. Check it. The ratio is not equal. The ratio is differing. The reason behind is that this calcium hydroxide counteract the ammonia chloride sublimation. That's why we are using this one type of the ratio. Now I am going to the your diagrammatic preparation, how it is being prepared. Check it. Here is the diagram before you in which we are taking a round bottom flask and that round bottom flask is somewhat tilted. Fine. This is your what? Drying tar. Drying tar which has a quicklime. This quicklime is your what? Drying agent. A cork, here the cork is there being attached so that no leakage can be there. It is set up in a proper standing position. In between of that one, the delivery tube is there. And these round bottom flasks and your drying tar is being connected through the delivery tube. What is happening in this one? Here, the calcium hydroxide and ammonium chloride is being heated. When it is being heated, then the reaction starts. And there will be a formation of what? Your calcium chloride with that one ammonia gas and the water molecule. It will pass through this delivery tube and move to this one, this one tar. Here it is being collected by the downward displacement of air. Here what is there? It has the somewhat water is there. Because in the product form the water is there, it is wet. It can be dried from the quicklime. Again the question arises, why only the quicklime is being used? The reason behind is that the other drying agents like concentrated sulfuric acid, phosphorus pentoxide, anhydrous calcium chloride are not being used because the ammonia is mostly what is basic in nature and it will react with them. Only calcium oxide, means the quicklime, is used as a drying agent. After the drying agent, it can be collected in an inverted flask gas jar by the downward displacement of air. Again, the reason is there. Why? Because it is lighter than air and highly soluble in water. Therefore, it cannot be collected over the water. Now I am coming to the reaction part. Which reaction is going on in this preparation? That is ammonium chloride reacting with the calcium hydroxide. There will be formation of a calcium chloride, water and ammonia. After this one, ammonium chloride preparation, next is laboratory preparation, that is metal nitride. Metal nitride is being prepared in the lab, but we are not using that one because this method is costly. What is happening in this one? In this one, the metal nitride like the magnesium nitride or aluminum nitride being treated with the water, and there will be a formation of the magnesium hydroxide with ammonia. Same with the aluminum hydroxide with ammonia. In both the cases, the ammonia is there and the setup of that one preparation is like this. Here we are using again the round bottom flask. That round bottom flask having a thistle funnel. This thistle funnel purpose is that so that the water can be entered drop wise. Here the delivery tube setup is there. Again your tar collection tar is there. Drying agent is used and ammonia gas. Same this one as the process start. Magnesium nitride react with the water and there will be a formation of the ammonia gas that can be dried by the drying agent and collected here. And the remaining substance, which is the remaining, that is magnesium hydroxide or aluminum hydroxide being present in this round bottom as it is. In a which form? In a liquid form. Next, after that, as these types are which are your dry ammonia. Next, we are proceeding to the aqueous ammonia. When we are considering the aqueous ammonia, means that the dry ammonia is being dissolved in water. Then only the aqueous ammonia is forming. That aqueous ammonia diagram setup is like this one. You can check it. What is happening here? Here again the round bottom flask is there, which is tilted and a funnel delivery tube is being attached. By this one the funnel is attached, a trough with the water. As the heating process is going on, by the heating process, what is there? What the reactant are there here? Ammonium chloride and calcium hydroxide, the same one. The process will start, the ammonia gas will form, and as you know the ammonia is highly soluble in water, it will be dissolved in water. But as it dissolved in the water, some changes occur. As the ammonia dissolved at a higher rate than its production from the flask, the pressure of the funnel here, the pressure of the funnel above the water level, I'm repeating, the pressure above the funnel, above the water level decreases for a moment. The pressure will decrease and the contact this one ammonia in which the water is being soluble, that will rushes to the funnel, and the contact between the funnel and the water will what left for a moment. As ammonia is highly soluble, what it do? It will pushes the water down, and by pushing again the contact of the funnel and the what level of the water will maintain, and that is this arrangement is being used for avoiding the back suction. Always remember the round bottom flask should be tilted. If you are not tilting it, then what will happen? The product which is formed can be happen. It can go back, and the what is the breakage of the this one apparatus can be there. Next, after that one, we are proceeding to the manufacturing form. In the preparation, the last layer of this one preparation is there, that is at the industrial scale, at the large scale, at the mass scale, we are preparing it, and it in that one the Haber process. Here I am first of all considering the which one your Haber process. Haber process were named on the basis of the scientist. He prepared the ammonia, and that ammonia preparation was based on two factors. One was the nitrogen gas and second was the hydrogen gas. Nitrogen was obtained from where? It was obtained from the fractional distillation of liquid air. You have covered in the 9th standard how the fractional distillation of liquid air is being done. And hydrogen gas is obtained from the water gas, Bosch process, already covered in your previous classes. And the reaction is occur like this one: nitrogen 1 ratio, hydrogen 3 ratio, and there will be a formation of two molecules of ammonia with a heat. Heat means it is exothermic in nature. This exothermic nature helps this reaction to proceed further. This reaction is reversible, exothermic, and proceed with the decrease in volume. Here one thing is very considered, that is the temperature maintenance and your what? Pressure maintenance. Temperature should be 450 to 500 degrees Celsius, and pressure it is above 200 atmosphere. Here the catalyst is being used, that is finely divided iron, and the promoter, that is molybdenum or alumina or Al2O3. Now these are all the reactants and the conditions which are essential for the Haber process. Now I am proceeding to the flow chart, how this process is going on. The dry nitrogen and dry hydrogen, they are being reacted in the ratio of 1:3, and this 1:3 is being entered in the compression pump. Here the pressure should be more than 200 atmosphere. As the pressure is being maintained, what will happen? They will come in contact to one another. And after that one, they are being entered into the catalytic chamber, that is electrically heated, means the heat is being provided. The temperature is being maintained here. Catalyst will give its effect, and the reaction will proceed, and the rate of reaction here increases. After this reaction, what will happen? This reaction become very exothermic. It is passed down to the condenser with the cooling pipes, so that the system can't be blast. When the condenser process is over, then this liquid ammonia is being collected afterward. But one thing keep in your mind, students, this liquid ammonia is only 15% from whole the process. Means only 15% of ammonia is being prepared from this one. Remaining is unreacted portion, which is again reback. And it is again rebacking to the compression pump. Again the process is going on, and by this process again what will happen? There will be a formation of 98% coverage of ammonia. And we want the 98%, we don't want the only the 15%. That's why what is uncombined nitrogen and hydrogen is recycled back. This one reaction, check it, that is N2, 3H2, reversible reaction, finely divided iron, molybdenum as a catalyst, temperature 450 degrees Celsius to 500 degrees Celsius, pressure above 200 atmosphere, ammonia is forming with the heat. One thing on, this heat is very essential part, because when at the starting we are providing the heat, after that this heat only maintained whole the reaction, and we have to not provide again and again so much heat. This one we can also check it in your what setup form, how it is going on. Check it. Manufacture of ammonia Haber process. Here the nitrogen from the what? Your liquid air, fractional distillation, 1 volume. Hydrogen by the Bosch process, 3 volume. They are being entered in the compressor. After the entering the compressor, the pressure is being maintained and they are entering into the catalytic chamber. In the catalytic chamber, what is there? What pressure is being maintained, temperature is provided, catalyst is provided. For the activation of catalyst, the promoter is being formed. The reaction begins here at the higher rate. And after that, this reaction becomes exothermic. We have to enter this one to the cooling chamber, otherwise the system will blast. Cooling chamber, liquid is going inside and liquid is coming out. Means the hot liquid is coming out and the normal liquid, so that the process can be cooled down. And at the end, the liquid ammonia is forming. But this is not the end. This liquid ammonia is only 15%. This process is again recycled again and again. Up to that, the 98% is not formed. And the ratio is 1:3 here. That's all for today. We have done in this lecture whole the preparation, manufacture, journal preparation, laboratory preparation. Kindly go through it thoroughly, write it, learn it, and do all the chemical reaction with the writing. Otherwise, what will be there? It will mix up. Make the notes of all these things, and in the next lecture we will study about the your properties of ammonia. What are the properties of ammonia? We will do in the next one. Thank you so much and have a nice day.